So far we've done a lot of writing chemical formulas, and now we're actually ready to get into writing chemical equations. So, a chemical equation deals with one or more reactants changing into one or more products. And it's written with the reactants on the left side and the products on the right. For example, if iron and oxygen combine to make iron oxide, right here we have our reactants, which are iron and oxygen, and the product, in this case it's a singular product, iron oxide. Generally, though, we won't write them with words like this. We will write them with the chemical formulas. So we have some amount of Fe, iron, and some amount of oxygen. That's going to make Fe2O3. Okay? Now, this is what's called a skeleton equation. It's not showing how much of each we have. We're going to get into balancing and really showing how much of each we have in a little bit. All right, then you can have something like a catalyst, which speeds up a reaction. And it'll be written like this. This is an example. You have hydrogen peroxide in the presence of MnO2, and it's written up above the arrow like this, making water and oxygen. All right, so what are all these extra things that we haven't really dealt with yet? Well, here's a guide to what they all are. All right, so the plus is usually, separating the two reactants and the products, right? If you have H2 plus O2, and it's going to make some amount of water. The arrow, it's not an equals, it's a yields. These two reactants yield this product. Sometimes, and we'll get to this a little bit later in the year, to reversible reactions, a reaction that can go both ways, and that'll have this double arrow here showing it can go this way or it can go that way. After these, you'll have these letters showing what they are usually. So like with H2, it's a gas, so I would have the G in parentheses. O2 is also a gas, so I would have the G in parentheses. The H2O is a liquid, so I'd have the L in parentheses. So you have solid, liquid, and gas. AQ is an aqueous solution, something dissolved in water. So you might have something written like Na plus AQ, Cl minus AQ, to show it's an aqueous, it's in solution. Above the arrow, you might have this delta, or heat, to show that heat is supplied. Sometimes you might see it written as, here's a reactant plus heat yields some amount of products. And just like we saw a moment ago, a chemical formula written above the arrow just shows the presence of a catalyst. All right, that brings us to balancing chemical equations. And the common question is, why do we even have to do this? Well, because of the law of conservation of mass. It says matter can't be created or destroyed. So when we write a chemical equation, we have to keep track of everything. We can't lose anything and we can't gain. So, for example, right, hydrogen plus oxygen is water. So like I wrote earlier, there's some amount of hydrogen, and it exists in nature as H2, so we have to write it as such, plus some amount of oxygen, also exists in nature as O2, so we write it as such, is going to yield some amount of water. All right, so when we look here, we have to count how many of each are on each side. So here, there's 2 hydrogens on the left and 2 hydrogens on the right. So far, so good. But we have 2 oxygens on the left and 1 oxygen on the right. So if we left this like this, that would mean that 1 oxygen atom got destroyed, and you can't have that. So what we do is we put what's called a coefficient in front of this, kind of like we've done in class before. And this shows that there's 4 hydrogens on this side and 2 oxygens on this side. So now our oxygens match, but we have 4 hydrogens here and only 2 here. So if we put a 2 coefficient in front of here, that gives us 4 hydrogens on this side, 2 oxygens on this side. Here now we have 4 hydrogens over here and 2 oxygens, and they match, so we know we're good, and this is a balanced equation. So the final balanced equation is 2H2 plus O2 yields 2H2O. All right, so another example. AgNO3 plus H2S yields Ag2S plus HNO3. I'm going to rewrite that just because my scribble got in the way. AgNO3 plus H2S yields Ag2S plus HNO3. So now if I look here, I have one silver here and two silvers here, so I'll need two of these. So now my silvers are good. I have two nitrogens on this side and one on this side, so I'll put a 2 here. Now my nitrogens are good. Oxygens, I have 6 oxygens here and 6 oxygens here, so they're good. I have one sulfur here, so they're good. I have 2 hydrogens over here and 2 hydrogens over here, so everything checks out. Okay, so there are some rules. Not necessarily something you have to memorize these rules, but you have to get used to doing them in order, step by step. So the first thing, like I did with the water, I determined the correct formula for the reactants of the products when I said, all right, so it's hydrogen plus oxygen yields H2O. And I wrote the skeleton equation out. Okay, so now I determined the number of atoms, 2 hydrogens, 2 hydrogens, 2 oxygens, only 1 oxygen. So now then I balance the elements one at a time using coefficients. Okay? And very important, never balance an equation by changing the subscript. I didn't change these numbers. I added a coefficient to add now 2. So now I go back and check based on this coefficient. There's 4 hydrogens here. So I put a coefficient of 2 in front of this hydrogen and see that I have 4 and 4. And then 2 oxygens and 2 oxygens. And then I make sure all the coefficients are in the lowest possible ratio. I'm finding the lowest common denominator, and since there's a 1 here, that can't get any lower, so I know I'm done. All right, take a few moments before moving on to actually read through these and make sure you understand them. Write down any questions you might have, and we'll, of course, practice some of these in class. All right, that brings us to the end of 11.1, and I'll see you guys in